Today we're going to look at complex numbers, and then we'll be looking at operations of complex numbers and then solving some equations that end up having complex solutions. Now, the definition of I is the square root of -1. So if you would square both sides, you get an I squared here. Squaring the right-hand side cancels out the root, leaving you with -1. Make sure you remember both of these. Also, on your calculator, if you hit your mode button, arrow down so that the A plus BI is highlighted. So if it's not highlighted, arrow down to A plus BI and hit enter on it. So on a problem like this over here, we want to go ahead and solve it for x. So we'd want to take the square root of both sides. We get this. Remember plus or minus whenever you apply a square root. Now 16 is really a 16 times a -1. We know how to do the square root of that 16, and we could do the square root of 1. So we get plus or minus 4. The square root of that -1 is an I. Now you could write it as plus or minus 4i, or it's really two separate complex numbers of 0 plus 4i and 0 minus 4i. As a side note, if you switch the sign in between, like this right here, and switch it to a minus, that is referred to as your conjugate, denoted as z with a bar above it. So here we're adding complex numbers. Well, if you're adding, you don't need the parentheses. You can drop them. Now you're just combining like terms. -5 plus 4, 7 of the i's plus 9 of the i's. Subtracting. Well, you don't need the parentheses there. Distribute through your parentheses the negative here. Combine your like terms. -5 minus 2, 7i minus 3i. Here we are multiplying a couple terms together, so we have to FOIL first terms, outer terms, inner terms, last terms. Remember, I times I is I squared. Now we can go ahead and bring down that -10. Combine together our two middle terms, which are like terms. We get -I. Remember, an I squared from that first slide is -1. So it's really a -10 minus I minus 21. Combine together our first and last term here, which are like terms. We get -31 minus I. Over here we're squaring. Remember, squaring means multiplying by itself, so we'd have to FOIL first terms, outer terms, inner terms, last terms. And remember, I times I is I squared. So combine together our middle terms here, which are like terms. Also, we look here at the end, that's an I squared, so that's a -1. So instead of plus I squared, it's minus 49. Combine together your like terms. Now, remember, the square root of -1 is I. And so this would be really 2 plus 3 times the square root of -1. Remember, we don't like having square roots in the bottom. So remember what we would do in a problem like this here. What we did from chapter 1 is we multiplied the top and the bottom by the conjugate. That's where you switch the sign in between. So as an example here of why it works, here's a binomial and its conjugate. Really, it comes from differences of squares. If you FOIL that out, your inner and outer terms drop. Whatever you had to begin with ends up being squared. Whatever you had to end with ends up being squared. And when you're dealing with the square root, you want those terms squared. And so that's why we use the conjugate. So we're going to do the conjugate here. We're trying to get the I out of the bottom, so we're going to do the conjugate of the bottom. So multiply out the bottom, first terms, outer terms, inner terms, last terms. Now when you look in the bottom, the inner and outer terms drop, and I squared would really be plus 9 at the end. Notice we have no more I, which is a root, in the bottom. That's what we're trying to get. So we'd also have to then FOIL the top. First terms, outer terms, inner terms, last terms. Combine together the inner and outer terms here, and we get 29i. I squared here at the end makes it a positive 21. Combine together our like terms on top and on the bottom, and we get 11 plus 29i over 13. Do this problem on your own, then watch the video. So you FOIL the top, because we're doing the conjugate of the bottom, which is you're just switching the sign in between the two terms. FOIL the top, FOIL the bottom, combine together like terms on the top and on the bottom, and remember that I squared is really a negative 1, so it would be a negative 10 times negative 1 or plus 10. And on the bottom it would be a negative 1 times a negative 25 or plus 25. Combine together like terms on the top and on the bottom. So powers of I, we know I, we have I squared we said was negative 1. I cubed is negative I, because I cubed is an I squared times another I, so that would be a negative 1 times an I, or a negative I. I to the fourth would be an I squared times another I squared, which would be a negative 1 times a negative 1, which is positive 1. I to the fifth would be an I to the fourth times another I. Well, I to the fourth is 1, so it would be a 1 times an I, or I. Here, this would be an I to the fourth times an I squared, so it would be a 1 times a negative 1. Here, this would be an I to the fourth times an I cubed, so that would then be a 1 times a negative I. This would be an I to the fourth times an I to the fourth, or a 1 times 1, which is 1. So whenever you come along here, you could always write this as I to the fourth, and a plus I, which would be a 1 times an I. Here, this would be an I to the fourth times an I to the fourth times an I squared, so it would be 1 times that I squared, which is negative 1. Very similar along here. You can always write these as I to the fourth, which is always 1, and then you can go times what's left over if needed. So, as you can see, if your exponent's a multiple of 4, you end up getting 1. If it's 1 more than a multiple of 4, and that's what the 4n plus 1 means, then we just get I. If it's 2 more than a multiple of 4, you can see that we always get negative 1. If it's 3 more than a multiple of 4, you can see that we always get negative I. So, as we look down here, is 37 a multiple of 4? No, but 36 is. It's 1 more than a multiple of 4, so we get I. Here's 43. Is it a multiple of 4? No. But 40 is, so 43 is 3 more than a multiple of 4. 3 more than a multiple of 4 is negative I. 16, it's a multiple of 4, so that means we get 1. 33 is 1 more than a multiple of 4, because 32 is a multiple of 4. This is 1 more, so that means it's just normal I. Now, when you have a negative in a root, you must first simplify that root and get the negative out of the root before you deal with it. So here, this is a negative 1 times 25, so that's really a 5i there after your minus 3. Here, this is a negative 1 times a 36, so you take the square root of both. That's really a 6i after your 8. So then all you have to do is FOIL. Combine together your like terms in the middle. Remember that your I squared at the end times your negative 30 is plus 30. Combine together your like terms. Over here, we have a complex number equaling a complex number. As a side note, suppose you had something unknown plus 7i equals 12 plus blank I. Well, the only way these complex numbers can be equal is if the parts without i's, the box and the 12, are equal, and then the parts in front of your i's are equal. Same idea here. The two parts without i's, the 8 and the 2x, have to be equal. And then what's in front of your i's, not including your i's, just what's in front of your i's, so that would be our parentheses, would have to be equal to what's in front of this I of the minus 4. Now, once we can solve this, we can easily solve for x, and we get x to be 4. If you know x is 4, you can then easily solve it for y. So we can plug in 4 here for our x, and then we can solve it for y. So we're going to go ahead and solve this. If we just take the fourth root of each side, we're only going to get two answers, a plus or minus 3. We're going to set it equal to 0 and factor. Now, this is really differences of squares. What's been in the beginning that's being squared, an x squared. What's in the end that's being squared, a 9. So it's an x squared minus 9 and an x squared plus 9. You can easily see how to factor the first one because it's differences of squares again. So it would be an x plus 3 and an x minus 3. So we get a negative 3 and 3 out of the purple. Here, in the past, we have said sum of squares doesn't factor, but sum of squares really does factor if you follow this pattern over here. You know, differences of squares will give you this here. Differences of squares will give you this here. So you got to think about what's going on. How are you coming up with a 4? Well, it's the square root of the 16. How are you coming up with a 7? Well, it's the square root of the 49. So this is also differences of squares. You know you're going to have an x in the beginning of each one, and then you're going to have to do the square root of this to see what goes in the end. Same idea here. This is really two things that are both being squared and subtracted. What goes in the beginning of each one, you know, is x. What goes in the end of each one would have to be the square root of this, so you know that that's the square root of 7. So here we have x squared plus 9. Well, adding is really subtracting the opposite. So now what we have right here is set up just like this. Something squared minus something squared. Something squared minus parentheses squared. So you can put an x in the beginning of each one. Then what goes in the end is the square root of this right here. Well, the square root of negative 9 is a 3i. So x squared plus 9 really does factor into this. So that's what we're doing here. Our x squared plus 9 goes into that. We now have two things multiplied together here. Set each one equal to 0 because the whole thing's equal to 0. We get negative 3i and we get I. This is also essentially quadratic. You have three terms, two with variables, one where the exponent of 4 is double the other exponent. Because it's quadratic, we can solve it for what's in the box. So we can solve it for x squared. And I would encourage you to write x squared equals. What's in front of your box squared is your a. What's in front of your box to the first power is b. What doesn't have a box is your c. Plug that into your quadratic formula. Work out what's in your root, and remember to bring down your x squared. When you work out what's in your root, it ends up being 9, and the square root of 9 is 3. At this point, I'd work this out, since it's nice neat numbers, into a negative 21 plus 3 over a 54, which ends up just being a 1/3 negative. And then I'd come back and do the negative 21 minus 3 over 54. You work out the top, divide by 54, you get negative 4/9. So now I got to finish getting x. If I hadn't remembered to write x squared each time, I probably would have stopped with these ugly colors right here. But because I know I'm trying to get x, and I remember to write x squared for each time because it's x squared, because that's what was in the box. It's always the smaller of the two exponents when you're dealing with a quadratic. Now we can take the square root of both sides. And you should know that the square root of the top over the square root of the bottom is what we do for square roots of fractions. So you do the square root of the top, square root of the bottom. We don't like to leave roots in the bottom, so you do a special form of 1 of square root of 3 over the square root of 3. So we get plus or minus I root 3 over 3. Over here, we can do the square root of the top over the square root of the bottom. Square root of the top would be a plus or minus 2i. Square root of the bottom would be a 3.